Kick us off, Derrick.
All right, welcome everybody to the introduction to Summer of LabVIEW 2024. Thanks for attending. We'll get into a little bit of the history, but this is something Darren and I started a couple of years ago. And as labeled on the tin, we're hoping this brings some interesting ways to learn and practice LabVIEW to the community. So I'm D-Bomb, but we'll talk about DNAT first. He has been at NI for more than 25 years. Started off like most NIers do, a couple of years in AE. Nowadays, that's known as TSE, providing support to customers. Then spent 18 plus years in LabVIEW R&D. Skipping ahead a couple of bullets, he is responsible for Quick Drop. He has sped up my development time so much, it's amazing. And then now, these days, he's back in the support organization in a more official manner. And yeah, so most people might have known him from NI weeks of yore as the 7 times undefeated world's fastest LabVIEW programmer. Maybe that was an inside job. He made all of his own tools to speed himself up. And he does a lot of presentations. If you have user groups or anything like that where you're looking for content to be presented, he's got a whole website for you. He loves to rehash those and engage in community events.
Now it's my turn to talk about Derrick. So as you can see, he needs a haircut badly. So hopefully that's going to happen soon. Derrick likes to jump out of planes, believe it or not. And I think most of the time, probably every time, he wears a parachute. So that's why he's still with us today. There's a musician who's moderately famous named Kishi Bashi, and Derrick is in at least one of his music videos.
One for a couple of seconds.
Derrick was my colleague at NI in the TSE group for a few years, and we all, I would say about once a week, somebody asks a question to which somebody else responds, man, I wish Derrick was still here, because he was the one that knew those answers. Derrick's favorite LabVIEW feature is PPLs.
Project provider.
Derrick has a one wheel that he used to ride around the hallways of NI on, and I was incredibly scared every single time I saw him because I thought
no, that was Norm. Where's that one time, the incident with the copy machine when somebody else tried learning to ride it?
Yeah, no, that's not for me. But these days, Derrick works at Blue Origin, and that means that he's into rockets, at least somewhat. If you guys have never been to the arcade called Cidercade, which is down the road from here, that was one of Derrick's favorite places when he lived in Austin, and he probably right this very minute wishes he was there instead of here. Derrick is the only person I know of other than Jeff Kodosky and Stephen Loftus-Mercer who has made his own channel wire type. And yeah, you can find it in LabVIEW today. It's called the Bommarito. No, I'm kidding. It's not in there. Derrick rides a motorcycle. That is not something that appeals to me, but you can see that somebody with hair like that's bound to ride a motorcycle, right? Since I started reading the slide, Derrick has actually released 4 packages on VIPM.io. And finally, as you can see, Derrick really loves slides about him that have nothing but text on them and silly GIFs. Derrick, would you like to speak to the picture there with all the parachutes?
Oh, yeah, sure. That was a really cool jump I did, was it 2018, 2019 down in Florida? That was if you see in the middle there's a guy with a really small parachute. The thing on his feet is a wingsuiter, so they got out of the plane, hooked up. The rest of us built a big diamond. 6 people in the middle came out, and then they flew through the middle of it. That was the first time that's ever been done. It's probably my favorite jump ever. Interesting, not many people got to do it. So yeah, I like doing interesting things that not many other people do, like play with X nodes and make channel wires.
All right, so what are we here to talk about today? We're here to talk about Summer of LabVIEW. So Derrick and I started Summer of LabVIEW back in 2022, and we'll get into some of the history of it later. But our primary goal in this event is to grow excitement and prowess, programming prowess in the LabVIEW community. And the way we do that is by creating LabVIEW coding challenges. This is something that NI has done in the past, but it's been a long time. And so Derrick and I sort of re-kicked off the effort back in 2022. And I mean, it's fun to write LabVIEW code to solve a challenge or solve a puzzle, right? But in the interest of building up the prowess part of our goal, we try to come up with topics that include, learning about data structures in LabVIEW that maybe you don't use on an everyday basis, learning about algorithms, learning about frameworks. So while you're having fun and learning about these things, these are also skills that you can probably apply in your day jobs when you're not doing programming challenges, right? And hopefully, even though it's called Summer of LabVIEW, we're hoping that by providing all of these challenges to the community in an open source way and as VI packages that you can download, these are things that you can do year round. Your LabVIEW user group could try to do one of these challenges, for a given period of time, a month or a quarter. Your company could have internal competitions that use the challenges that we've put together, that the community has put together. And then just to practice LabVIEW, I mean, some of the challenges that we're about to show have a really simple premise. And so you can wrap your mind around it really quick and then just immediately start iterating and seeing, okay, how can I solve this thing? Oh, I solved it. How can I solve it faster? It can allow you to practice some of those LabVIEW skills. So, summer of 2022 is when Derrick and I first started Summer of LabVIEW. And when we started it, it was an internal NI event. So this was back when Derrick was my colleague in the TSC group at NI. And we started this contest just within the sales and support organization at NI, because that was the department that we worked under. And I managed to convince management to give me some budget for cash prizes. So that was one of the ways that we tried to drum up support or drum up interest inside of NI. You can actually win a cash prize. That is not something we're promising going forward, but it was something I was able to manage to get, in that first year. And we had 3 challenges. We had a Wordle solver, we had a maze solver, and we had what's called Square Battle, which is, we can mention maybe later. But we had an internal page on the NI network where you could log in and submit your challenges, and it was pretty cool. Derrick rigged up this pretty sophisticated system to pull down somebody's challenge and automatically run it through a test harness that told us, if they got the right answers and how, quickly it was able to do that. And the coolest part was that the web page that people submitted their answer or their challenge answers for, you can see a screenshot of it here. That's written in the GWeb module. And then the server machine that we had sitting at our desks, I think.
At your desk.
At my desk, actually had a web server that was written completely in LabVIEW that was pulling down all this information. Do you want to speak a little bit to the details about how all that worked?
Not particularly.
Okay.
If anybody has questions, feel free to ask me. But
if I recall correctly,
there's a web server package on VIPM.
Yes, that's just what I was going to say. So anyway, so that was the first year. That was when we managed to convince the higher ups at NI that this was worth spending our time on, spending some budget on to within NI build up some LabVIEW excitement and skills. So then last summer, summer of 2023, the competition was opened up to be worldwide. So it's no longer an internal NI thing. It was an event that was sponsored by G Central last year. And the whole LabVIEW community could participate. There was one challenge, which was Square Battle, which again, we might talk about a little bit later, which was the same Square Battle from 2022. And one of the things that was different, obviously we didn't have cash prizes, but we did have the Summer of LabVIEW badges that we offered to people that ended up, did every participant get one, or did you have to actually, yeah, I think every participant
Everybody that
got one.
submitted got one.
And Derrick redesigned the website, which you can see today, actually, summeroflaview.com, not written in the GWeb module anymore. And then,
PHP.
and then the winners were announced, and the square battles were demonstrated in a pretty cool graphical way at GDevCon in July last summer. So this year, 2024, once again, Summer of LabVIEW is open to the entire community. And we have multiple challenges to participate in this year, as opposed to last year where there was just one. So over the next, I guess, 3 months, starting next week, we're gonna be running 4 challenges, and each challenge is gonna last for about 3 to 4 weeks. And we're still going to have everything go through summeroflaview.com in terms of submitting your answers. So why don't we talk about what the challenges are gonna be?
Well, we're gonna, I think, get started now.
All right. So our first challenge for Summer of LabVIEW 2024 is a word search. So this is probably our simplest challenge that we're starting with. And if you look at the screen, that is basically the front panel you're going to be working with. The inputs to your VI, which you're going to have to write, are a 2D array of strings and a 1D array of strings. And the 2D array of strings is the letters. Hopefully everybody in this room at least knows what a word search is. It's a grid of letters, and you have to search through that grid to find a list of words. So we can see the grid of letters is one of our inputs, and the words you have to find is the other input. And then the output, don't be scared if you've never seen this data type in LabVIEW before, but the output is a map. And in that map, we've got key value pairs, where each key is the word that you're trying to find, and each value is the indices of the letters in the grid that will basically spell out that word. So if I just real quick talk to the first entry in the map, we can see that it's the word blue. If you go over and look in the grid, you'll see the word blue is in the top row, starting at column 1. So if we look in the map, we see that the letter indices for the word blue are row 0, columns 1 through 4, and basically every other word in the word search is returned with that information. Derrick, can we open up the VI and just talk real quickly about how a solver might work for this challenge?
Sure. Do we want to do the video first or after?
It's up to you.
Okay. You asked for the VI, you will get the VI.
All right, and we'll just speak to it really quickly here.
Oh, not that one, the example one.
All right, so this, I will tell you, is a bad way to solve a word search, but it does work. So let's say we're looking for the word blue, like I was talking about before. I go through the entire grid of letters and find every B that I can find. And then for every B, I spider out in all 8 directions and see if that spells the word blue. And as soon as I find a spot where that happens, that's the solution. Yes, Bob?
You can go diagonal?
Yes, in word searches, you can go diagonally. So this code here, I won't talk through every node, but I'll just tell you that's how it works. It finds every first letter of the word and then spiders out and tries to solve it. That works. It's cool that I've got a VI that works, but it's slow. So when you download this challenge, you'll be able to at least look and see a way to solve it, but you're going to want to figure out a better way to solve it than what I did. Yes, Bob again.
Sorry. Am I correct that you can't use this, if you've got 2 L's in it like yellow, you can't go you can't,
you can't change directions.
you can't use the letter twice.
Correct. You can't change directions and each letter has to be there individually. Yes, that's how a word search works. Another question in the back row.
Did y'all notice y'all had red going twice?
Yeah, so that was intentional. So no matter where a word is in the grid, if you find it in some spot, that's fine, as long as you found the actual word and not something else. All right, so that is an example of the word search challenge. We will give you the VI. We'll give you sort of a way to test your code. We'll give you a crappy sample solution, and then we'll give you a place to fill in your own code.
So yeah, so we're going to look at what is the overall process for doing this. So summeroflabview.com. There's a sign up in the upper right. There's a handful of fields here. The only 3 that we need filled in is a username. Some of these challenges are going to have leaderboards associated with them. So as people are making submissions or as you're making updates to your submission, you can see where you rank relative to other people. We'll use that username as the display. Your email, if we have a problem with your submission, you're using some node you're not supposed to, or there was some problem where we couldn't run it with our score, we'll email you. That's the only thing we'll use that email for. And your full name, just so we know who you are. It's actually a really good way to catch bot registrations. Does the name make sense or is it a bunch of gibberish? Company, so the rest of these fields are optional with the exception that I do need confirmation from Mallory that we will be giving recertification points for participation. So if you have a CL, CLD, CLA, you could use this as recertification points. I'm 90% sure we'll be able to do that. I need that last final confirmation. So we will collect what your NI account email is, the email you have signed up with on ni.com. We will not ever email that. So if that's a business email because you need that linked to your business account, we're not going to use that. We're just going to give that to NI when we submit the list of people that should get recertification points. All of the rest of this is just as we get more and more participants, there might be fun ways to group it up and look at the stats of, what level of certification do people have, what countries are they from, what regions of the world they're from, maybe just come up with interesting ways to group the results. I already have an account, so I'm not going to register. Also, the challenge isn't live yet, so I can't show it off on the public website. But but I can hopefully run this local copy quick. What you would do is you would go to the challenges page and you'd see word search shown there. You click on that. That's the page you'll go to have your upload button to submit your entry. It looks like that's not working. The other thing to look at is these are available on VIPM. Oh, there it is. So you can go to the word search page. This has a link to the VIPM.io page that has the package. We're going to distribute all of our challenges on VIPM. You can install with VIPM from here, or you can download it, then install it, or just open VIPM, search for word search. You'll be able to get a copy of it. And once you are done with your submission, in the build specification is a submission zip, build specification. Right-click that, build that. That'll give you a zip. And then you would upload this zip with the upload submission. And that's going to take a minute to load because I just started that server. So you could browse to that zip, upload it. If you are interested in recertification points, make sure you check that box. You upload it. We then have it. We'll run it. We'll score it. Any questions on that? The other thing of note is there is a link to the Discord server. So on the Discord server, we have specific channels for each challenge. You can discuss if you have questions about the implementation or questions about something you're trying to accomplish. The whole point of this is you're trying something new. If it's not, you can help other people, but we want you to start using more features of LabVIEW, getting some practice. So by all means, ask questions. Do not be shy about asking questions. You do have to introduce yourself in the introductions channel. That's just our one extra step to make sure we're not getting a bunch of bot accounts on the Discord server. Once you say, hi, I'm Derrick, we'll give you full access to the Discord server, and then you'll see the chat channels for everything else. So if you show up and you're like, there's 2 channels here, nothing here that Derrick said was there, that's why. We just have to give you access. Did I miss anything?
I think you covered everything. And while you were talking, I realized I should point out that we're going to have mechanisms in place when your code is uploaded to automatically score it. We will do our best to make sure that everybody's submitting legit code and not trying to fool us in some way. I think there was a hand back there first.
I was just going to say, speaking of bots, are you guys going to ask Nigel to submit for these 2?
You better hope that your code is faster than whatever Nigel comes up with, because if it's not, that's embarrassing. Michael, I think you were next.
Once you've submitted, is it gone? Like, can I submit an improvement later on?
Yes.
Okay.
Submit many times. We are going to have a leaderboard displayed on that page, and whatever the active challenge is, there's going to be a leaderboard on the front page for anybody that's logged in. We're not going to post the usernames unless you've already actually registered and made it through registration. But the whole idea is climb the leaderboard.
What version of LabVIEW do you prefer?
2020 and up.
Okay.
We will be running them in the latest version of LabVIEW that's released, so 2024 Q1 right now, I think.
Yes.
But all of the packages are published back in 2020, so any version pretty much you would want to be using these days unless you don't use interfaces.
I'm assuming that the word search grid and the word list are blank in the input, the VI that should be submitted. It should work for anything.
Yeah. So the question is, does it matter like what the actual grid and words and everything is? No, you're just giving us a VI, and we're going to be passing in a grid and a word to your VI. I just have the default value set there so to give you something to play with.
That's
I promise.
The next slide.
The grids. Oh yeah, that's right. Let's move on to the next slide.
And it could be of any size. The grid could be of any size. The word list could be of any size.
Exactly. So I don't think we're going to tell you guys how big the grid is that we're going to use. And I don't think we're going to tell you guys how many words we're going to pass in, other than to say they are going to be very large. So just keep that in mind. So just to kind of summarize the word search itself, first of all, bit.ly/SOL word search, it takes you to the VIPM.io download page. So your primary goal when you're writing your word search is to just get something that works. Yeah, if you can get that, that's cause for celebration. Now, once you get that, now you want to see if you can write a solver that's fast. The solver that I included with the code is slow and dumb. I described to y'all how it works already. Y'all want to come up with something that works much more quickly. And like I mentioned, we're going to throw some really large grids and really large sets of words into your algorithm. So if you can get yours to work with the red, orange, blue, yellow, that's great, but you're probably going to want it to work with something that's quite a bit larger.
It's also really hard to tell the difference between execution times when they're down in like the 6th decimal position of execution time.
Correct.
So we're gonna make it work for its prize.
Right, and going back up to the primary goal, your solver needs to work. If your solver does not work, we're going to assign a time of infinity to how long it took your solver to solve. So you probably won't be very high on the leaderboard if your execution time was infinity. And then, like I mentioned at the beginning, what we're trying to do in addition to having fun is to also help you have areas to learn. Sets and maps is a data type, are some of the newest data types in LabVIEW, and this word search, you're returning a map with your solution. If you don't know that much about maps, this is an opportunity for you to learn about maps. And I have a presentation I've given all about sets and maps that you can then go check out and learn about those data types and build up some of those skills to help you solve. We had a question back here.
So do we have a leaderboard for other challenges as well? Like say if I participate in all the 4 challenges, and I want to see like where do I stand in all 4 challenges, like a global leaderboard kind of a thing?
Every challenge will have a leaderboard.
Each individual challenge has one.
But
it's
not
going to
the
be really
cumulative.
hard to come up with a global per summer leaderboard, just because the level of the different skills that are in use with some of the different challenges, how difficult it's going to be. Sometimes it's features that people aren't familiar with. The one we're running last is maybe the lowest barrier of entry to start tinkering with, but it can scale to really lots of effort if you want to. An overall leaderboard would be really difficult to come up with.
Okay. And one more question is, can we use any of the VIPM data structure available?
Yep.
Okay.
Yeah, if it's publicly available, we'll allow you to use it. I guess now is probably a good time to say that there are some things that are not allowed. You're not allowed to use VI server. You're not allowed to use communication, so no TCP, no UDP, no trying to dial out to some other server to run some algorithm or get answers. No file I/O. Don't try and access stuff on my computer. And
DLLs, we're not going to let you call a DLL to solve the word search.
No call
Sorry,
library
guys.
function nodes outside of the ones that are in the analysis toolkit and some other stuff. We do have code that runs that automatically checks for that kind of stuff, and we will be looking at it. So initially, the leaderboards will probably not be updating very often because we're going to have to inspect and make sure we don't have any gaps in that stuff, because we're going to be running arbitrary code from people giving me zips on the internet. Whew, oh boy. But yeah, if it's on VIPM, we'll be, especially if you're using something on VIPM that we haven't installed on the scorer yet, it'll take us time to get that installed, but we'll get it installed and run your entry.
All right, any other questions on word search before we move on to talking about some of the other challenges?
One clarification we talked with Bob was,
I had a misconception.
Okay.
When you put down a word, it has to be, all the letters have to be in a straight line, correct?
That is correct.
Horizontal, vertical, or diagonal.
That's correct.
Okay.
And backwards as well, so watch out for backwards.
Say?
Backwards.
Well, of course.
Of course.
But that's still a line.
Of course.
Yes.
yeah.
That was my misconception.
Yeah, the question he is having is this Boggle or is this word search? And this is word search, not Boggle. So.
Excellent clarification. All right. So the next challenge we will have after word search is Wordle, which if you have not played Wordle, you can go to the New York Times website and play. It's a daily puzzle that they have where you have to figure out a 5-letter word in 6 guesses. And with every guess that you make, they tell you which letter you guessed is not in the answer, which letter you guessed is in the answer but in the wrong spot, and which letter is in the answer and in the right spot. So in the picture up here, we see that our target word that we finally got on the 6th guess was nomad. And we can see whenever we guessed jumps, it told us that the M was in the right spot. Whenever we guessed plane, it told us that the A and the N were in the answer but in the wrong spot. etc. And then we made our guesses. I tried to think of words that described Derrick. That's why I picked those. So what you're going to do is you're going to...
I was wondering why that looked... caught my eye.
What you're going to do is you're going to write a solver for Wordle. And the way your solver is going to work is, once again, I tried to make the interface to the VI that you have to write as simple as possible. You're going to write a VI that has one input and one output. The input is basically the black, green, yellow representation of your previous guess. And then the output is your next guess. So you can see over there we have minuses and pluses, and I guess we can also see some stars in the results there. But minuses mean the letter's not there. Pluses mean the letter, basically minuses are black, pluses are green, and stars are yellow. And this is all explained in the code, so you don't have to remember any of this. But basically, this is how the Wordle is going to work. And if Derrick wants to open up VI and just sort of show how you're going to interface with the code. So you're going, again, this is all templatized code that you're provided. And again, I provide you a simple solver that is crappy. You're going to want to come up with a better solver than what I came up with. And really quick, I'm just going to talk through, ultimately the part of this solver that makes it the crappiest is the part at the very end. So the part on the left side of the diagram is basically analyzing the pluses and the minuses and the asterisks and what was given back to me. And basically keeping track of guesses that we've made before, goes in and tries to figure out, okay, based on the fact that, and I'll just make up one here, based on the fact that there is an M in the second space, as I iterate through all of the possible words and I encounter the word apple, there's not an M in the second space, so I can kick out apple and never worry about it again. That's kind of what this logic is doing. Well, here at the very end is where's the crappy part. Because at the very end inside of that flat sequence structure, I basically got all of the possible words that are left after I've eliminated stuff, and I just pick a random one, and I say, okay, this one's my next guess. And so I'm narrowing down by being able to eliminate things, but I have no smarts in terms of what I've decided my next guess is going to be. It's just going to be a random word I haven't eliminated yet. So that's where you can probably think of some better ways to do this and making a more educated guess and what the answer could be, like, I don't know, figuring out what letters are the most common letters in English words. And once you have that information, make a guess that's got a lot of those letters in it, as opposed to just picking a random one like I do here. So that's how my crappy solver for the Wordle engine works.
Yeah, and so the first challenge, word search, we're actually scoring it based on time. This one we're scoring based on how many guesses it takes for it to get the words. We are not measuring time, but you will have a time limit. You can't let this run for half an hour. We won't let your entry run that long. So efficiency is not the focus, but don't ignore it either. This one runs relatively quickly, so this is very safe. Just keep that in mind.
Question from Bob first.
Where do we get the list of words?
We give it to you.
Okay.
We give you all the possible words the answers could be.
Thank you.
Yep. Another question back there.
How big is that list of words? Is that the Wordle list, or is that like
I believe
Collins?
I used the Wordle list, which I think is 30-something thousand, 80-something thousand. I can't remember how many words, but yes, I think it's the official Wordle list.
Any resources on sets versus arrays and, okay.
I'm going to talk about that in a minute. Yep. Another question.
Should we be worried about the runtime memory?
Should you be worried about what?
Runtime memory.
I'm sorry.
Yeah, we're gonna run it on a machine that can use up to like 8 gigs of RAM probably. So again, the main thing, yeah, if you eat up all the memory, you've eaten up all the memory, you will not complete, you get a score of infinity on that run.
I hope with a word list of 80,000 words, that won't be too much of a problem.
No,
if it was
my
80
question
million
is
words, maybe.
more like, will the runtime memory be considered?
Nope.
No.
Nope. It's just the number of guesses.
Yes. Yeah, you can have a super efficient, and Derrick's right, this code actually runs really fast, but it takes a terrible number of guesses. It solves in like 8 to 9 guesses. So that's bad. So
it does ship with this. This isn't exactly what the project will look like yet. I'm still working on packaging it up for VIPM. But the easiest way to test this is I'm going to take Darren's simple solver, drag it into the path, and I'm going to leave word to test empty because it's just going to randomly pick a word. If you wanted to test a specific word because there's a specific word that gives your algorithm trouble, you can do that. But I'm just going to run this, and we can see here's the sequence of guesses that it went through.
You want to zoom in on that? You want to zoom in on that a little bit?
Absolutely.
So yeah, you can see that my simple algorithm is black.
Oh, it doesn't like the live zoom. Okay, so
Cool.
I'll just...
So in my simple dumb algorithm, my first guess is always the word crane, because that has several common letters in it. So that's always going to be my first guess. And I was told that crane has no letters that are in the target word. So my next guess picked a random word my next guess picked a random word that did not have any of the letters C, R, A, and E in it. And it picked oh wait, but it's got an E in it. Okay, so something's wrong with my crappy algorithm. It's even crappier than I thought. So it picked a second word. There weren't any letters in that one. Picked a third word. Oh, we found a few letters. The M and the H are in the wrong spots. So I'm going to make a guess that has the M and the H in different spots. We guessed oomph. We got the MPH in the right spot. At this point, we've narrowed down the list of possible words to pretty small. There's probably not too many 5-letter words that end in MPH, and we were able to guess it in a couple of guesses after that.
I've never heard.
Mike's coming.
There is. I'm very unaware of Sumpf,
Doesn't matter.
Mahua, and Kaibs.
I guarantee I don't know all of the words in the dictionary either. So, but remember, we give you the list of words.
Okay.
So
okay.
those were pulled from the list of words that were given to my algorithm.
And it's a computer algorithm. The computer doesn't know words either.
Question.
This is the normal mode, not the hard mode, so it can guess anything,
That's correct.
anytime.
So for those of you that know about Wordle, there are two different ways to play, one of which requires you to make guesses that utilize letters you've locked in previously. This does not do that.
You don't happen to remember what the average score was when we did it in NI, do you?
When we did this puzzle at NI, the player who won, I believe his average number of guesses was in the 4.5 range.
Yeah, it was like 4.2, 4.3, somewhere around there.
Which is pretty darn good. All right, so if we head back to the slides. So again, your goal is to write a solver that actually works. If you're not careful, the way this whole thing is written, you might have a bug in your solver where you get back what the previous guess was, and your solver doesn't know how to make a guess. So you want to make sure to write a solver that works, and once you do, write the solver that takes the fewest guesses, like Derrick just said. We are going to pass in a large collection of words into your solver. I think it might have been 50 or 100 words when we did it in back in NI days.
I thought it was like 1,000.
Oh, maybe it was 1,000. It was a bunch of words, and we're going to take the lowest average guess. And if at any point your solver does not give us a correct solution, again, infinity guesses. Now, since this is a situation where we are sort of dynamically calling your code and we're running things through an engine, the Wordle engine is built on DQMH. So if DQMH is something that you don't know or something that you've wanted to learn more about, again, this is one of those challenges where you can take the opportunity to learn more about a topic in LabVIEW that might help you in your day jobs when you're not solving challenges.
And the engine is written in DQMH. You're not exposed to DQMH in your solver code. You saw it's the one input, the one output, but the code is there in the project for you to look at.
Yes, and there's multiple sort of hooks into the Wordle engine. So as you start exploring the code and realize, oh, I don't just have to run this simple tester like the one that Derrick just ran. There's some debugging capabilities that the Wordle engine gives me to debug things. Again, that's where some of those things where you can learn more about DQMH come in. And then another area of learning is sets. So in the sample code that Derrick showed with my dumb solver, it uses arrays everywhere. You might find that the set data type allows you to work with, I guess, more elegantly with this particular challenge because you've got a set of words and you're going to be probably removing things from sets, making your own sets, adding things to them. So you might find that the set data type is something you want to learn more about because this challenge is tuned toward possibly solving with sets instead of arrays. So something to think about.
Q. So this is the first challenge that isn't written by us. This year we have Quentin Aldridge submitting a challenge that we will be using. So we're going to let Quentin speak about it.
Yeah, so I decided to submit a challenge this year to help Derrick and Darren out. And so I don't know if you've heard of Reversi. Sometimes it goes by its trademark name, Othello. Essentially, the goal of this game is you start off with just two pieces in the main diagonal, right in the center, two whites and two blacks. And the goal is to essentially bound the opposing player. So if, let's say that you are the black pieces, you want to bound either in a column or in a row or in a diagonal and have a white piece, or let's see, you're the black pieces, so you have a black piece, a whole bunch of white pieces, and then you place another black piece and you capture all of the pieces that are in between. And the goal of the game is you take turns that way and you want to have the most pieces on the board. And so, basically, it's an 8x8 grid, and there's two ways that you can submit a submission for this one. If you are not object-oriented, there's just one VI. That VI, you get the current layout of the game board of the black and white pieces, or black and white spaces that are taken in the empty spaces. It automatically decides for you what all of the possible moves that you can go. So you don't have to do that analysis. It already tells you everywhere that you can go. And it tells you, there's a random coin toss at the start of each game to tell you if you're the black player or the white player. So it'll tell you what player you are. Then all you have to do to tell it, the output, is which one of those do you want to take. What position you're going to place your next piece on. And then it calculates how many pieces you took and all of that stuff. So you could do something really easy. I programmed two players. The object-oriented, you could also submit an object-oriented submission, and then you just override, what's the VI name that you override? I can't remember.
I'm working on cleaning it.
Oh, you're cleaning. It's changed from what I had. Okay. So he's rewriting it. But basically, there could be some trade-offs learning object-oriented because you can save some state in between, or maybe you just want to do it non-object-oriented and do it the easy way. It's up to you. But I give you two examples. The object-oriented way is the dumb player, and it's just looking at the possibilities and it's randomly picking one. So it has no strategy, just random selection. The non-object-oriented one, I programmed with a little bit more smarts, not much. All I did is if there was a option that existed on the main two diagonals, then it would pick it first. If there wasn't, then it would randomly pick from everything else. And it's kind of interesting that one differentiator of having it pick along, if there is an option along the main diagonals, picking one of those first, made that one win 2/3 of the time compared to 1/3 of the time going against each other. So, that might give you some hints on something that you can do to make the algorithm better.
And so this is what testing it'll look like. We can run it.
So yeah, this one's a little bit different in the fact that you're going to go up against the other players on this one.
Yeah, so this one there will not be a leaderboard on the website for because it's going to depend on how everybody does. But there is this test. We'll probably be sharing implementations that people are interested in sharing via the Discord, and we'll work out how to more easily share those. But this is what the game will look like. You get this loading screen where you can choose the players or just run a tournament of every available player on disk that it can find. I've upped from 1 game per match to 3, and I've slowed it down from a 1 millisecond pause between rounds to 500, so we can actually watch it a little bit. So it started with the 4 in the center, and we could see it flipping back and forth between the players and making the move based on what their implementation chose.
One thing that's kind of fun on this one too is if you do choose on that first screen to pick the players, one of the players is human, and so you can play against your algorithm if you want to. It basically just has an event-based thing that waits for you to take a turn manually. So there is the possibility with an 8x8 grid that's 64. So there is a possibility of ties, but that's why we run a bunch of matches and we take kind of the average wins. At least I figure that's how we're scoring it. But these guys are handling the scoring. So
we got
I just helped with the engine.
Any questions on this one before we move on? Okay, finally, the one that I implemented for this year, it is Formula G. As you can guess, we're going to be doing some racing. The whole point of this challenge is to implement driving logic for a race car. So your VI is going to choose the throttle from 0 to 1, no throttle, full throttle, and steering left to right, -1 to +1. 0 is drive straight. Those are the two numbers you have to come up with. That's it. Turns out you can actually have a really simple implementation. So hopefully this has a really low barrier to entry for people to start tinkering with. This one is real time. It's not hard real time, but the engine is trying to call your code 25 times a second. So if your code takes longer, you'll just be updating your control less often. So we're gonna dive right into this. Let's see, 3. And I'm gonna show 2 demos. So this is the example that that is distributed with it. And this is as little logic as it can take to steer the car. The car gets 10 measurements, 5 in the front, left to right, 5 in the back, left to right. So in this cluster, there's a front and a rear, and then 5 elements in each of those. And this is just comparing the left and right and steering away from the wall that it's closest to, or steering towards the wall it's furthest from, whatever coordinate space you like. But this can be as simple as it can be, except this can only run at a relatively slow speed. And let's see what the actual game looks like. So as this comes up to this turn, it's going to start turning. We can see the steering that the code is turning back. This has a chart just showing the track that the car took throughout it. You can see the indicators of what steering it's turning back, how fast it ended up going, what its throttle is. The whole point of this is to try and get the lowest lap time. I'm not sure how many laps will run per car. It'll probably be in the 3 to 5 range, and whatever the fastest time within that number of laps is, that'll be your score. So try and get the lowest lap time. This basic implementation does laps in about 37 seconds. And so your idea is to come up with better steering mechanics and throttle control. This can only run at a single speed. If I try and make this even just a little bit faster, it's gonna pretty quickly crash into a wall. Nat. You can get an overhead view, so not super detailed. And you can show the range lines, which isn't really showing up here great. And if I try and do the dynamic zoom, but there's the red lines, those are the measurements it's simulating and sending back to your car as if you had LiDAR. It's all perfect measurements. Your code is also given position, angle, speed, all of that. Kind of a neat way to start getting into kind of robotics style challenges. And if it does get stuck, it hits a wall, you can reset it back to the beginning. Here you can see the simulation lines, the range lines. It's taking measurements along. You can pause if you need to debug. The other thing you can do is you can leave, we're not doing reentrancy or anything like that. So if I resume this with the VI open, I can see all of the values going through. I'd be able to probe this and you can debug your code while it's running. So hopefully kind of interesting for people to play with. There was a hand.
So I'm assuming you'll be able to test this across multiple different maps, just so someone doesn't hard code a best possible solution or whatever.
Yep. Yeah. So this map is just, I mean, this is the first one I came up with, but we will have a handful of different courses. This map pretty much has every kind of, we're not going to be throwing in any extra obstacles. These are all of the same radiuses we'll use in any map we come up with. We might make them a little smaller, might make some a little bit bigger. Maybe I'll try and come up with a way of having multiple cars run at once, so we can have more interesting screen recordings, and there won't be collisions between the cars or anything. But kind of feeling out where this one is going to go based on if 3 people submit, we'll probably have one where we just watch them all run at once. But the more people that submit entries for this, the more things I'll try and come up with on how to do it. But ultimately, this last lap time is the thing you're aiming for, even if we're just showing them all together. The last lap time is what matters. Any other questions?
Yeah, sure. So you fail if you hit a wall. The green space doesn't really matter. Looks like this one stays on the line.
Yeah, I said I could live debug this, so I can play with the steering sensitivity. I can make it bounce back a little bit further, harder in turns. That's where this chart for the track is useful. You can see if it's overcorrecting, undercorrecting, seeing if it's tracing the same path every time. You can play around with that a little bit, but if I make this go faster, this actually doesn't automatically reset or anything, but this will eventually crash and it's just stuck. So you hit the reset button. I don't have the reset button resetting the current time yet. I'll be fixing that, but yeah, the idea is you got to be able to make it through the course. You got to be able to make it through the course multiple times. So like I said, this can't go any faster. This is the simplest implementation. You make yours a little bit smarter, you should be able to go quite a bit faster. Another neat thing, so if anybody here was at my presentation yesterday? 2 people, cool. So you all saw this. I'm glad most people weren't here, but I'm gonna switch the implementation over to this other car control. This one doesn't have automatic math. So the thing I presented about yesterday, the community training initiative, we're coming up with a set of standard firmware and LabVIEW wrappers for Raspberry Pi Picos. Trying to get people interested in developing community-provided trainings and a really cheap, affordable hardware platform to do that on. So I've written code that the first time my code gets called, it's going to initialize the connection to this guy using the LabVIEW wrappers we have, initialize 2 analog input channels. I've got 2 potentiometers here. And then every call, it's going to be reading those 2 analog inputs, reading the potentiometers and using that to converting that from the DAC values on the Pi Pico and steering it. So we'll see how terrible I drive with this. So I can change the throttle up and down and steer, but I can't do both at once and try and talk. Trying to steer with little potentiometers is surprisingly difficult, but the main thing here is there's all sorts of ways you can play with these. You can start to introduce hardware, getting people to build, input stuff, integrate that with these. Try and have fun with it, try and experiment with it. There's all sorts of fun stuff you can do. And yeah, so here's the details. There's the 10 directions. We will be scoring against new map layouts, so don't hard code logic for a specific map layout. The whole point is you run a lap or 2 to build up speed. If you want to go crazy, you can build a map representation and chart your plot. Like, you can go crazy with this. I have a feeling most people will not. I will not be. Not that my submission counts anyway. But yeah, so this is, the idea is it's something hopefully engaging to tinker with, but you can go crazy with it.
Follow-up question was, it looks like is the finish line an obstacle, or can you just pass through it?
It is an obstacle. It's got to be able to make it through the center of that gate. That is the only obstacle on the course.
got several questions.
Yeah. So what is it that you're controlling? You're
controlling this. Okay.
Is it the speed of the car?
It's the throttle and the steering.
But you can. Are they constant or are you?
No. This is going to get called 25 times a second if your code is running quickly.
I see.
And this code 25 times a second is getting updated distance measurements around the car. In this pattern.
And then you adjust the steering and the throttle
exactly
for that 4 milliseconds.
Yep.
Okay.
And if your code can't run that fast, if your code takes 100 milliseconds to run, you'll be at about a 10 hertz update rate. So as fast as your code can run, that's how frequently you can update up to 25 hertz-ish.
Is it only one lap?
One
lap around the track, or?
We will count your fastest lap. I'm going to say we'll run 5 laps, and your fastest time out of those 5 laps will be the score for your entry.
Okay.
So yeah, if you drive really slowly the first 2 laps, but then you can manage a lap that you can complete in 5 seconds, that would be really impressive, and we want to accommodate that. So this is the calendar for the rest of the summer. Will be, today, big green highlight. So starting Sunday, word search will be active on the website. It's actually up on VIPM right now. You can get it. You can start playing with it if you want. We can't stop you. But the site will be accepting submissions starting on Monday. It'll have the challenge entry listed. And then June 23rd, we turn off word search, turn on Wordle, and then the same thing for Reversi and Formula G. As I mentioned when Q was talking about Reversi, I'm doing a little bit of cleanup and packaging on the code. None of the other 3 besides word search are available yet on VIPM, but over probably the next 2 weeks, hopefully, all of them are available. You can start playing with them, but these will be the ranges of time when we're accepting submissions for them. So we need to finalize this, but at the end, sometime probably in September, probably sometime in September, we'll run a live YouTube event or something, and we'll show off what all the challenges were, and if we needed to run any tiebreakers, find out who tried cheating and calling code that they shouldn't, and maybe we come up with some interesting ways to exercise people's entries.
I was going to ask, is there going to be either a checkbox or just a way to sort of say, hey, open source my solution, or it's...
We're going to look into that. I do want to add a checkbox for that specifically so we can put previous entries in, but like strip their block diagrams maybe, or password protect them. So as we get more collections of them, we absolutely encourage everybody to keep track of your entry on GitHub, GitLab, Bitbucket, whatever.
I'm more thinking once you have the solutions that won or top whatever, it'd be good to be able to share. Because one of the ways of giving back to the community is not just having them participate, but seeing what efficient code does, right? So
that's what we want to try and run in September is cover some of that stuff, find some of the interesting implementations. So we're gonna, we have your email. We're going to email it, hey, is it cool if we talk about your code? Do not password protect your code. Do not strip block diagrams. If we can't analyze your code, we're not going to run it because we can't know that you're not trying to do anything suspicious. That is something that happened last year. A bunch of people tried password protecting their code. Unless you give us permission to show off your code, we will not be showing off your code. We will ask you. So everything like that is good. But we absolutely want to try and share that back. So there's a QR code. If you need help getting to summeroflabview.com, Discord link up in the corner. And how else can you help? Well, we need more ideas for challenges. Absolutely, if you want to run challenges at your companies and your user groups, we'd love to help you get started with that. So Maze Solver is actually already built. That's one of the ones that we ran internally at NI. We'll be rehashing Square Battle at some point. Want to try and make that a little bit easier to get into. I've got some fun ideas now that I've got game engine builds integrated in LabVIEW, which is how I was doing the Formula G. I want to do stuff like Lunar Lander, Bass VE. Is that just what we call him?
I don't know what else to call him.
I forget what company he's at, but they've got a battleship implementation and has said we could use that for Summer of LabVIEW, so we'll be working on packaging that up. But more ideas are always better. You know, we've got aspirations of turning this into the advent of code for LabVIEW. We'd love for help for that. There's just a handful of things we try and aim for with the challenges, make it accessible, easy to get into. And absolutely join the Discord, ask us questions, and anything else?
Remember that if you want to join the Discord, it's very easy. Go to summeroflabview.com and there's a link to the Discord on the main page. That's how you get there. You can get to everything you need from summeroflabview.com. Question?
So are all the previous Summer of LabVIEW competitions available online for like people who wanted to learn LabVIEW?
Right. So in 2022, the competition was internal to NI, and we created some VIPM packages that are available. I looked recently and I saw that Word Search and Maze and Square Battle were there. And so those are the packages that we used to run the challenges back in 2022. And then the Square Battle one was used again in 2023. So the code is there. We don't have any publicly available like results from the internal NI one. The results from the 2023 one were demonstrated at GDevCon last year. Any other questions or comments before we wrap up the very last session of NI Connect 2024?
Does anybody else have any challenge ideas that they think would be fun? Even if you don't participate.
I have a Connect 4 one if you want. Maybe next year I'll have that ready.
Oh, we're talking to you.
Yeah, I have a couple.
Thinking maybe like the Warlord 26 for Atari 2600 game with the rotating paddles.
Do love those paddles. One thing I'll share that's actually kind of a funny anecdote from when we ran this internally to NI. This was as Derrick and I were discovering ways that people could cheat our system. There was an engineer at NI who wrote I believe this was a Wordle solver, who used VI server to get information about the VI that was calling his code, and was able to actually, with some private scripting methods, read the value going through a wire on that block diagram that had the solution word. So his solver could always get it in one guess. That was when we said, maybe we shouldn't allow VI server in these solutions.
Hey, it's like racing. If you don't say it's explicitly against the rules.
Yeah, it was
and I did not say that last year. So so last year, people came up with an implementation that would use the VI server property node or invoke node to get a screenshot of the front panel. They do image recognition so let me pull up Square Battle. They would figure out where the opponent squares were. What am I doing here? There's LabVIEW. I moved all of my icons for this presentation and now I'm lost. I'm very easily confused. And so is LabVIEW, apparently. Oh, I clicked on it, but this wasn't showing up. So we'll do a Square Battle.
And to clarify, we're not doing Square Battle this year, but we might next year.
Just so you actually know what we're talking about.
Yep.
Actually, you know what? I have the recap video, I think.
Which will load faster, the recap video or LabVIEW?
We'll find out. Okay, now I don't have the recap video handy.
Any last questions from you guys? Hopefully you all have had a good NI Connect. You've had a nice brainless hour to do in the last one. Didn't have to really absorb anything other than summeroflabview.com. Man, who wrote that progress dialogue? Oh wait, it was me.
I'm wondering if this is a package version where I forgot to tell it to close, which looks to be
It
the
probably
case.
is. All right, so just imagine a grid where there's a bunch of squares of different colors who can go assassinate each other. And we had a submission that, like Derrick said, took an image of whatever the current status of the board was, which you're normally not allowed to do, and figured out the coordinates of where the opponent's squares were and just went immediately to them and killed them. You're not supposed to be able to know how to do that. So this is what square battle looks like. A square, just again, we'll do this real quick since you guys technically we're after time. A square can either move, stay in its same spot, attack a spot next to it, or replicate itself. Those are the 4 things a square can do. So you can see the green squares and the blue squares have a variety of different, obviously they're all moving around, but squares are replicating, squares are moving. If a square is next to a square of the opponent, it will attack that square. And that's kind of what's going on here. But what Derrick was describing was somebody illegally figured out how to get a screenshot of this picture, figure out where all the opponent's squares were, and go kill them. I don't believe that is the one that we're watching here.
No, that was not in any of the official scoring.
Okay.
We disqualified it. So there has been expressed interest that we should have an open category, specifically for the people that we want to see how creative people can get. We will not accept them via the online submission, but if you're like, hey, I came up with something really neat, tell us about it on the Discord. We'd love to see it.
Like a race car that somehow blasts through the walls to get to the finish line. All right, I think that's all we have, you guys. Thank you so much.